Okay, let's dive right into an incredible medical mystery for today's explainer, one that connects a very common metabolic condition to a completely unexpected part of the human body. We're going to unpack a major systematic review and meta-analysis, and honestly, if you or someone you love is managing their metabolic health, the findings we're about to explore are absolutely crucial to understand. Just to wrap our heads around the sheer scale of what we're talking about here, currently, an estimated 40.1 million people in the US alone are living with diabetes. That is a massive portion of the population, making it the seventh leading cause of death. And because it's so incredibly prevalent, the medical community has spent decades mapping out exactly how this disease impacts our systems over time. Because of all that research, we're already super familiar with the well-documented complications, right? We know about the risks to the kidneys, the impact on vision through retinopathy, issues with cardiovascular health, and the nerve damage associated with peripheral neuropathy. These are the standard things doctors heavily monitor. But all of this raises a really fascinating question. Could the very same disease also be silently damaging our ability to hear the world? For a long time, studies on this were pretty inconclusive. Scientists suspected a link, for sure, but they just couldn't definitively prove the association. See, in past studies, researchers actually found physical, structural changes inside the ear of diabetic patients. We're talking visibly thickened basement membranes right within the cochlear capillaries. But there was a major catch. Just because the physical structure looked different, they couldn't conclusively prove if that structural damage directly caused an actual measurable loss in hearing. Designing the hearing investigation. To finally solve this mystery, researchers knew they couldn't just throw everything at the wall to see what stuck. They had to set incredibly strict rules. For their inclusion criteria, they only accepted high-quality studies with age-matched controls. And their exclusion criteria? Totally ruthless. They strictly threw out any study that relied on self-reported diagnoses or mixed different types of diabetes together. They needed pure, undeniable data on type 2 diabetes. To give you an idea of their rigorous process, they started by casting a huge net, pulling in 2,650 initial citations. But after applying those strict rules we just talked about, they whittled that mountain of research down to just 18 pure qualitative studies. That is exactly how you separate the true signal from the noise. The incidence and age factor. First things first, they needed a baseline. So they defined hearing loss as a pure tone average greater than 25 decibels in a patient's worst ear. Essentially, if a sound had to be louder than 25 decibels, which is roughly a whisper, just for you to hear it on average, it was officially flagged as hearing loss. The results, honestly, they were striking. When they ran the numbers across the combined data, they found an odds ratio of 1.91. In plain English, the general diabetic population is nearly twice as likely to experience hearing loss compared to healthy controls. That is a highly significant link. And it actually gets even wilder. We all know that our hearing naturally degrades as we age, right? Well, when researchers specifically isolated the under 65 age group, that odds ratio jumped to 2.10. This is absolutely vital because it shows a much stronger link between the disease and hearing loss well before natural aging heavily factors in. The diabetes is acting as an independent accelerator. Frequencies and thresholds explained. So what kind of hearing loss is actually happening here? While patients had worse hearing across all levels, the loss wasn't uniform. At a low frequency of 500 Hz, the difference was around 4.5. But jump up to a high frequency of 8,000 Hz, and the difference climbs to almost 8. This shows an increasing magnitude of loss at higher frequencies. It means that things like crisp, high-pitched speech sounds, the consonants that give language its clarity, might become subtly, but noticeably harder to distinguish. Tracking brainstem signals. But this investigation didn't just stop at the ear itself. Researchers followed the biological trail straight into the brain, using auditory brainstem responses. Think of these like a neural highway. The data showed that signals, specifically at the peaks known as wave 3 and wave 5, were physically delayed in diabetic patients. The signal literally takes longer to arrive. And get this, participants showing this neural delay had had the disease for less than 10 years. The final patient takeaway. So let's bring all this back to everyday life. The ultimate verdict here is that type 2 diabetes doesn't typically cause a sudden, profound, deafening loss of hearing. Instead, it's a subtle, mild hearing loss that gets worse at higher frequencies, combined with a slight physical delay in the brain actually receiving the auditory signals.
Of course, science is never totally finished, and a few mysteries do remain. For instance, researchers couldn't fully account for a lifetime of environmental noise exposure. But crucially, they pointed to a massive question for future studies. What exactly is the relationship between our long-term glycemic control and the severity of this hearing loss?
Which leaves us with this really powerful, proactive thought to end on today. As we look at holistic health, managing diabetes is generally framed around protecting your heart, your eyes, and your kidneys. But based on this data, could meticulously managing your blood sugar also be the key to protecting exactly how you hear the world around you? It is an incredible reminder of just how deeply connected our bodies truly are.